This is it, okay? This is our starting point. This is the results of our previous tests. The first thing we'll do, let's open up a new test environment here, like that. And let's see here. Let's take a buggy result like grok, and let's see if we can fix it. We'll start by fixing a buggy result because grok is broken. We'll see if we can fix the bug of grok, and then we'll start adding more balls, and we'll ask for maybe UI elements to like change the number of sides in a dynamic way, so you can actually modify the kind of shape that we're dealing with. So let's try that. So let's copy this code here. Let's get 2 browser windows side by side. This is 3.7, and we want a 3.5. Okay. Okay, we'll just say the following 2D physics simulation is buggy. The ball does not stay inside the cube. Please fix this physics simulation. I'll say, please debug and fix this physics simulation. Should be sufficient. This is for Claude 3.5 Sonnet, and we're going to put it head to head against Claude 3.7. Same exact prompt. Let's go. And we'll put the result into here. So we'll call this bouncing ball simulation v2. What do I do? Let's do a text. We'll say this is debug fix grok's broken simulation. This is the prompt that we gave it, and the first result. I keep doing it a little bit too early. I want to change the. I want actually a header 2. This is going to be Claude 3.5. And then after that, we'll do Claude 3.7. So this is Claude 3.5's approach. And we can see right now, it doesn't look great. I think possibly, let's document it. So this is an interesting failure, right? So it is a little bit harder to fix broken code than it is to write code from scratch. I mean, that I think is intuitive to human software developers. When you're dealing with broken code, you're inheriting a lot of stuff that can be a real challenge. So Claude fails at this task of fixing grok's broken simulation. This is the version that we gave it, and let's put in our code. So this is Claude 3.5. Clearly a little buggy. It's possible we could have helped it out by giving it a little more instructions about the nature of the physics, like we want elastic collisions against the walls or something. But even so, I think Claude, that probably wasn't the issue for Claude. So let's look at Claude 3.7. Woo! Look at that. Look at that. That's amazing. Okay, let's not waste any more time. That's awesome. That's awesome. So Claude 3.7 got it. So I love when we can feel that differentiation. That is super exciting. Header 2. This is Claude 3.7. We got it. HTML. Is that the right copied? Yeah. Boom. Okay, let's go. Let's go. So we're going to keep pushing this, right? So let's take Claude 3.7's good output, and we're going to do a new test. So we have this on my clipboard now, Claude 3.7's working output, and let's think about what we can do to this. Let's keep pushing this. Let's start by adding in multiple balls, and I want the balls to collide with each other as well as the walls. And that's going to be our starting point. We're going to go with 3.5 and 3.7. Start a new chat. We always got to be very careful with these tests not to accidentally mess this up. Start a new chat. So we have 3.5 and 3.7. The prompt is going to be, please modify this 2D physics simulation to simulate multiple balls moving and colliding. Let's pick an exact number instead of multiple. Let's say let's start with 3. 3 balls moving and colliding simultaneously. Balls should be able to collide with each other as well as the walls. And we'll just sort of start with that, I think. And then after that, we can bring in UI elements. And the UI elements will be like, you know, dynamically change the number of balls, change the number of edges on our polygon that's rotating, change the speed of rotation, potentially change the speed of the balls. So we can make this more and more complex. Okay, there we go. Please modify the 2D physics simulation. This is 3.5. Send it off. We'll let that run. Let's come back here. Let's say we're now going to do text or, yeah, text. And we'll say this is multiple balls. And then we'll do header 2. This is Claude 3.5. And then we'll do HTML. Is this rotating with the square? It's hard for me to know. I'll just say this looks freaking amazing. This looks amazing. It's possible that Michael's right, that the lines aren't perfectly straight. It's not so obvious to me if that's true or not true. I'm going to ignore that right now because it's like not the easiest thing for me to personally verify. Obviously, we can like all just slow down the footage and like put a ruler on the screen and like figure it out if this physics is right or not. But let's call this like an intuitive kind of level test, right? This is like a smell test. Like I'm not interested in actually, I'm not going to stress about whether or not the physics are perfect right now. That's just not important enough for me as part of this benchmark at this point. Let's just say this looks freaking amazing. And I'm super satisfied. So I think Claude 3.5 knocked it out of the park. And the problem with that is I don't actually necessarily want to give this a 3.7. I mean, we could. The problem is it's just, yeah, our goal is to sort of create differentiation here. Let's just see what it does. We'll give 3.7 a shot. I suspect it's going to be hard to differentiate. Let's go. Claude 3.7. The next piece I think is going to be really fun is to add UI elements here. Once we start adding UI elements, I think things get really cool. Let's see what happens here. So let's add a new tab here. Start new chat. Let's see what 3.7 does. If 3.7, you know, makes easy work of these, we're going to really have to start thinking creatively about how to write harder tests. I have a list for myself of some harder tests. In addition to harder tests, it could be fun to pull up Cursor and start working with Klein and see what we can do in that environment. You know, there's all sorts of games, like platformer games we can challenge it to make, simple platformer games, 3D, Wolfenstein style games we can ask it to make. So yeah, I think the sky's the limit. This again looks great. I mean, the disappointment here is in the fact that we didn't really differentiate the two results so well, I think. So we need to, I guess, ask harder challenges. So let's go. Let's say I want UI elements to change the number of balls, to change the speed of the balls, and to change the number of walls on the polygon and the speed of rotation on the polygon. So let's take Claude 3.5's code and let's construct that prompt. Sorry, 3.7. This is 3.7. Yeah, not 3.5. So let's construct a prompt. Let's say like this. This is the code we're starting with. Please modify this code to include the following UI elements. Slider to change the number of balls. Let's say slider to change the number of walls on the rotating polygon. Let's say slider to change the speed of the balls, and then let's say slider, yeah, to change the speed of the rotation of the polygon. And we can add a button to start. I like that idea. A button to start and stop the animation. All these UI elements should affect the simulation in real time. Okay, let's copy this in. We'll start with 3.5. We'll see if 3.5 can handle it. Let's go. Just refreshing here. 3.5. Cool. Let's see what we get. UI elements. It's working. So far, we haven't really tested 3.7. The goal here is to really push 3.7 to the limit today, to really see where it starts to break. So I suspect we might have some work to do to get there. Woo! We broke 3.5. Okay. All right. Okay. I'm going to say we broke 3.5 for now. Let's go 3.7. Let's see if 3.7 can handle this. Looks like 3.5 is not, I mean, obviously, unexpected capacity constraint is not a 3.5 issue per se. Obviously, that means the server is struggling right now, which isn't necessarily the most surprising thing, considering 3.7 just dropped. But anyway, let's try 3.7. Let's see what we get. Okay, cool. So far, no server error. Yeah, Mugiwara, regarding your comment, in my testing, Claude 3.5 is significantly better than Grok, including Grok thinking. That's just my testing. Of course, there's a lot of different tests out there and a lot of different opinions and use cases, but that's in my real world and test scenarios, I've been much happier with Claude 3.5 for code. Yeah, we're talking about code here. Okay, well, 3.7 has gone to work on this problem. I mean, 3.7 thinking exists. We haven't tested it yet, right? I don't think I'm wrong about that. 3.7, am I wrong about that? Yeah, it has, thinking mode. It has an extended thinking mode. Here we go. So Claude 3.5 failed on this on at least two different ways. It didn't give me pure HTML output. And it also had a bug where when we saw it within this sandbox environment, the balls seemed to leave the square. So we're going to just call this a fail across the board for 3.5. I feel pretty comfortable doing that. 3.7 looks like it succeeded. Let's copy it into the file and let's play with it. It looks like we got it on 3.7, which is cool because I love to see that differentiation here. So can we pause? We can pause. Let's go back actually to here because there's no... The screen truncates it, which is a little bit annoying. Let's pull up the speeds. Ball speed. Is it going to work? Sort of. The balls are all going different speeds, but I think the average speed went up. And if I drop it down, yeah. So that's working. Let's speed up the rotation, please. Put some more kinetic energy in the mix. It's possible the ball physics is a little wonky. I don't really know. It's sort of hard for me to judge, but I don't care. I mean, I'm more than satisfied with this result. I think this is amazing. I think this smashed 3.5. Incredible to see this level of differentiation. Yeah, super exciting. Okay. Ising model. We're just going to do it in the Claude UI here. That's our plan. Let's just go to 3.7 and let's just ask it to impress us. We're going to keep it simple. Please give me a fully a web app that contains an Ising model physics simulation. It should have UI controls for changing the temperature as well as, okay, be careful of context explanation given that you have example on cursor, right? Interesting, okay. It should have for changing the temperature, as well as a live chart, as well as let's say metrics that describe the overall state of the simulation. I'm trying to think how to phrase this properly. What we're going to do is we're going to pass this to ChatGPT. Please help me improve this LLM prompt for clarity. Oh, shoot. Stop that. Let me try that again. Copy. Please help me improve this LLM prompt for clarity. Let's go. This is what we want. We want an Ising model simulation. Ising model is a beautiful physics simulation that models phase transitions with a really profound effect. Okay, let's try that. Looks good to me. Copy it in. Please create a web application featuring Ising model physics simulation. The app should include an interactive UI with controls to adjust temperature and display metrics that describe the overall state of the simulation. Okay, the simulation should be visually represented with, and the UI to be intuitive and responsive. Let's go. 3.7. After this, we can feed it at 3.5. And then after this, I think we'll, yeah, we could try thinking mode, Deadly Sin. That's a good idea. It'd be nice thing to try for sure. We can get 3 sort of results now. We can get 3.5, 3.7, and 3.7 with thinking mode. I like that. Okay. Okay. Still thinking here. So what is the Ising model? The Ising model is a 2D physics simulation that models a lattice, a 2-dimensional lattice. Of course, the Ising model is studied in n dimensions, arbitrary dimensionality. Oh no. We're gonna have to try again. That's a shame. Let's get rid of this. So we're looking at a 2D lattice of magnets. So every magnet has a positive and negative pole. And the magnets are next to each other. And so there's a magnetic, they exert a magnetic force on each other so that they want to be aligned. The magnets want to align themselves with their neighbors in the grid. But there's also a temperature parameter. And the temperature parameter introduces randomness into the simulation. So this is a metaphor for phase transition in the physical world. Temperature in the physical world is the average kinetic energy of particles in a system. So you're introducing kinetic energy into your model. It introduces random flips of the, there we go. And as the temperature changes, the long-term behavior of your lattice changes. So let's see what we got. Critical temperature is 2.27. So the critical temperature is when there's a phase transition. So above the 2.27, you get pure randomness. That's what I expect to see. So far, I'm not seeing it. Oh, here we have to click start. That's why. Great. So this is a high temperature over 2.27 critical threshold. We get a random, yeah, I made it using React. That's sort of funny. We get a random output because the temperature introduces this randomness into the model. As we make it colder, the temperature goes down. We get a coalescing of uniformity because there's a force of sort of uniformity the magnets want to align themselves with each other. So this is sort of the force that wins out. And there's a critical temperature at which the two forces are sort of exactly balanced with each other. And you get like a fractal pattern at that critical temperature. And the critical temperature is different for every different dimension. So that's the Ising model. This is below the critical temperature so that the long-term behavior is basically uniform. Okay, this is really nice. I mean, I've been talking about the Ising model, not been focusing on the output, which is maybe a mistake here. I mean, this is gorgeous. I mean, this is really gorgeous. I would love to test 3.5. I think this is amazing. Because the output is in React, we're not going to be able to copy this into my notebook, which is totally fine. I don't need to. That's not really the point right now. This is a gorgeous simulation. This knocked it out of the park. I'm super impressed. Let's try 3.5 and let's try 3.7 thinking. And let's see if we get different results. So let's copy this prompt. If 3.5 can get close to that, I'd be impressed. I bet 3.5 can do a simpler web app. That's my prediction here. I think 3.5 will give me an Ising model that is simpler. A really nice feature is when these are sort of plotted on like a two-dimensional grid. So you can sort of see over time how the energy changes in the system. You know, another thing you can imagine having would be like a speed or a frame rate kind of dial, so you can like slow it down. But anyway, the principle is that at the 2.27 mark, you get fractal patterns emerging, which is a pretty cool concept. Anyway, let's come back here. All right, error running an artifact. So interesting. So I think, yeah, so 3.5 tried and failed. So what we do in these situations is let's give 3.5 another chance. We'll say we have an error. Yeah, try flexing with Claude, right? Let's give it another chance, right? We pass the error back to Claude. Let's go. This is agentic coding. I apologize for the oversight. We need to properly import the responsive container. Ooh, it tried. It certainly tried. These are the charts I was talking about. Is this a 1D? This is a 1D Ising model? No way. No, it says it should be 2D. It doesn't look like 2D to me though. So this is broken. This is broken, which is great in a way. It's great in a way because it allows us to differentiate between 3.5 and 3.7, right? It allows us to show the difference between the capacity of these models, which is super, super, super cool. And it's really exciting or scary, depending on your perspective of the rate of progress that we're seeing. Anyway, these were the charts I was talking about. How as the temperature changes, the energy, the long-term energy, either goes up or equilibrates. But this model is broken. Let's give 3.7 a try. I want to see. Let's give 3.7 thinking a try. Let's just see what that does for now. And we can maybe even modify the prompt a little bit. We can say, the app should include an interactive UI with controls to adjust temperature and display key metrics and the overall state of the simulation. I'm going to add 2 words here. Over time. This is nudging it in the direction of making those nice charts that sort of graph the properties over time. And we're going to try this for extended. And we'll see if we can get an improvement over 3.7 with 3.7 extended. Yeah, that's possible. Single suggests maybe they downgraded 3.5 for 3.7. That's plausible. Very possible. Okay. After this, what's next? I think after this we can open up Cursor. And we can try some coding with Klein. And I think we should make a game. Maybe we'll start with Tetris. I think Tetris is a nice benchmark. I've done it on my stream before. I think last time I tried Tetris, it took me about 20 minutes or so. I mean, you could obviously find the video. The thumbnail of the live stream has Tetris on it. You can obviously find the video and see if I'm right about that. Ooh, that's really nice so far. Metrics over time. Oh, this is so nice. This is better than, how do I make this full screen? Is it possible? It's got to be possible, right? I mean, I could do it in CSS, but there's no way to make it full screen. This is gorgeous. This is just gorgeous. It's going much slower for some reason. So I wonder if there's a performance issue. This is what I was talking about. This is beautiful. They even have a what am I seeing section. 3.5 didn't give us that. Yeah, nothing like that. This is gorgeous. This is huge. I mean, this is like scary. Scary good. We're at the critical temperature here, so we expect to see sort of this, emerging scale and variance. But if we were to pick up the temperature, we're sort of struggling against like a frame rate issue here. Maybe unclear why exactly, but this is running slowly. So maybe there's, like I said, performance issue. Either way, I'm super impressed with this. If I was in college and I was studying the Ising model or double pendulum or physics simulations, as I did back in the day, I mean, what a tool this would have been. When I was in college many years ago, I had to write these myself. But, students today wouldn't have to. All right. Very cool. Let's move on. Let's go to cursor. Let's think here. Let's go to AI code. Okay. Let's make sure we have Klein set up properly. We're targeting Claude 3.7. And let's say, ooh, that's surprising. It's saying the model ID is not provided. The model ID, there we go. Now we're good. We're good. Okay. False alarm. Let's see if it can make Tetris. Please make a basic Tetris app. Web app. Claude 3.7. I have a baseline for this. In a past live stream, ooh, you might run into some issues today. Okay. Well, this experiment is might be short-lived. Here we go. After like 4 or 5 retries, we finally convinced it. Yeah, but this might be an issue still, because we need to be able to make many requests. As I've been trying to say, you can compare this run to a previous run of the same task to see if we've improved between now and, let's say, I don't know, like 3 weeks ago or whenever that was. Okay, retry. Retry. At a certain point, we'll have to give up. I don't know how persistent we want to be. This is the previous output right here. What's possible? This was 2 months ago. Time flies. Okay, it's already making a commit. So I'm not worried about the commit. Let's run it. It costs 30 cents. The pricing seemed to be exactly the same between 3.5 and 3.7. Let's go. Let's go. Okay, this is much, 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 much better. Like, way better, right? Claude 3.5 could not do this in one shot. Claude 3.5 had a crazy amount of bugs that had to be worked out. And the point of that live stream was to sort of demonstrate that it's possible to debug code written by AI. Like, the point of that live stream was that you can get a bad output from an LLM and work with it and massage it and improve it. But this is totally different. This is a one-shot and go. This is a completely different result. I'm quite flabbergasted by what I'm seeing here. That's shocking to me. So instead of playing Tetris all day, we should probably move on to another experiment. I want to make sure we can clear some lines. I'd love to get a Tetris first, but not so well suited for that. Yeah, it just works. It just completely works in one shot. Compare this to the last live stream 2 months ago. This was not a one-shot job. This was a lot of going back and forth and debugging and creating a debug panel and feeding errors to the model. A lot has changed in 2 months. That's crazy. That's crazy. We should push this a little further. I mean, there's a lot of things we could do with this, right? I mean, let's just try something else here before we move on to a platformer. A platformer is always a fun challenge. Before we move on to that, we could just say, please add a dramatic and explosive animation. I don't know if we'll be able to do this. This is a hard. I wouldn't know how to do this in vanilla JavaScript. Whenever a row of blocks is cleared in the game. I don't really know how to do this in vanilla JavaScript. I would need to find some libraries or something. I mean, I'm already starting to think about what are the implications of this, you know? One of the biggest limitations we have right now in the world of AI coding is related to context size. Because, of course, you know, code bases are so huge that modern LLMs can't, you know, they can only see a small snapshot at any given time. So I think that's going to need to be another piece of this puzzle as we move in the direction of AI coding. But, I mean, this is an incredible step forward, it seems. So it's noticing that maybe it's trying to include too much code at once. Oh, base64 encoded audio data. Holy smokes. For real? What is happening? Have I tried code? Mugiwara, are you asking about Claude code, I assume? I mean, yeah, Claude code, is that what you're asking about? I have not tried Claude code yet. It's going to create an explosion sound file. That's really ambitious. What is happening? Well, we're certainly making progress now. I've successfully implemented the dramatic and explosive animation, finally. Let's see. Okay, well, we have to clear some lines, I guess. So pause, spacebar drops bricks and pauses the game, which is a bit of an annoying bug. But we'll live with it for now. Okay, it made a crazy sound effect. We also need, there's also an issue with the scroll bar. Okay. So what happened? Well, we're getting a cool sound effect. I'm not seeing any explosive animation. So let's press it on that. Because that is what we asked for. It says visual effects, colorful particles explode outward from the center. Are there any errors? I'm not seeing any colorful particles. Console, last try here. So there's a few bugs which need to address. We'll give it one more chance to redeem itself. Okay. I don't think there's going to be any. Oh, there were particles down there. Huh. So the particles were not aligned with the bricks. Weird. Okay. Let's ask it to make some improvements. I want to get this to be a little better. Let's see if we can improve this up. So let's say when I press the space bar, the game sometimes pauses and the page scrolls downward. What else? What other issues did I have? Pressing the down arrow key should also not scroll the page. I don't think the explosive particle animation is aligned with the line of blocks that are getting removed from the UI. Is there anything else to fix? We'll start with that. Those are the main bugs that came to mind. Retry. Yeah, I do want to try Claude code. This is having issues, of course, as we've seen. Okay, let's give it a shot. Let's see if we can make this like feel nice. I assume you guys can hear the animation, the sound effect, right? The sound effect is pretty cool. It's like a retro gaming explosion sound effect. I sort of love it. So we got the prevent default in there. Now we need to fix the alignment of the explosive particle animation. I see that the effects canvas is created and appended to the game board container. The canvas is positioned absolutely, but there is no specific positioning top left defined. This might be causing the misalignment. Let's retry. This retry interaction is so funny. It's like we're interfacing with such a brilliant AI tool, but like the infrastructure is like this limiting factor. So you have to like keep tapping retry to get it to work for you. It's so interesting. Okay, let's go back to my browser. Let's refresh the page. Let's close this down. Let's see if this is gonna work. Press start. Let's go. So far, so good. Yeah, it's not doing The color scheme's a little bit suspect here, but live with this for now. Let's go. It's a little hard to see where I'm aiming. Okay, it's not great actually. I'm in a bad spot Tetris wise. Oh no, I need two of those. I sort of dug myself a hole here. Okay. Let's go first. Oh, it's still misaligned. Still misaligned, but it's cool. It's dramatic. I'm pleased. Okay. It's at least it's visible. All right, what's next for us? Let's make the most of our time together here. Let's take a look at code. What is this anthropic code thing? Okay. Tips for getting started. Let's ask to make 2048. Please make a 2048 web game with cool looking animations. What has it done? It's deleting everything. Okay. No. Do you want to make no. Let's start over. We want please create a web app that will host multiple web games, including the Tetris game currently found in this folder. Don't overwrite the Tetris game, but refactor the code and rename files so that we can add more games and browse them from a single home page. Okay, yeah, it's making a new directory. Great. Yeah. Now at this point, we'll just say yes to everything. Yeah, I'm not even reading it. Just do what you want. But I'm excited to see what it does with this. As a reminder, I talked about this a little bit before. I have a previous video on my channel from 2 months ago where I used Klein to make 2048 and Tetris. And the takeaway from that video was that it was not easy. I mean, I was able to do it in, let's say, about 40 minutes both games. So let's say about 20 minutes per game or so, approximately. Maybe a little more. But it required a bunch of back and forth. Tetris today was much faster. Let's see if 2048 is also faster. I've created a multi-game web application that includes a homepage with a gallery of available games, the existing Tetris game, and 2048 game with animations. That sounds great. So to find it all, yeah, it's right there. Let's give it a shot. Okay, looks, I guess let's call it retro. Let's see if Tetris still works. Okay, it still works. Back to home. Yeah, it totally works. It totally works. And it was one-shotted. We were not able to one-shot this 2 months ago. This is totally working with the animations that I asked for. Amazing. Freaking amazing. This is going to change, yeah, coding forever. Not because of 2048, but I mean, this is different. This is totally different.